Hello, this is Said in here, and you are watching the last tutorial about activities in mandatory occupancy simulation model. In this tutorial, I will explain the basic theory behind path planning, in other words, calculation of potential fields, and I would be giving you two examples that I think will be very useful if you are planning to use OSM in your projects. Okay, so let's start with the theory. The calculation of the potential field is based on the optimal control theory. I took this definition from Wikipedia. What you need to understand from this definition is that we want to find a path and we have a desire to minimize the overall cost, which is their optimality criterion. We have cost functions, some equations to calculate the cost functions, and we have control variables. So the reason that I modeled the data with the cost functions, not with the satisfaction, is actually based on this theoretical background. And that is the takeaway from this slide. So let's take a look at that with some illustrations. The space which looks empty to many of us is not empty. Actually, we don't feel the space is empty, and the space is always filled with qualities. When we are traveling through a path from one point into another, we are experiencing different qualities, and we are experiencing the qualities that change in each point of the path. So for instance, at this point of the path, the discomfort that we may experience is actually this one, and then we can simply integrate all of them. And if we integrate all of them and add the effect uh, of the length to that, then we will get the overall evaluation that we have from that path. So we can actually write a mathematical formula. I'm not going to describe the details, so this is our first and last formulas that you can see. So we have a path, and we want to integrate the distance cost and the quality cost in this path, and to capture the total cost of the path. And the distance cost is a constant number, which we saw that in previous tutorial. It was a parameter. The quality cost is actually a mixture of different parameters also, and the goal is to minimize the total cost of the path without making any of the factors negative. All right, so with that said, we are actually, I feel confident that I have told you everything you need to know about the path calculation model that we have. And I want to give you some examples. So this is a building layout, and I have prepared the OSM environment for that in order to show you what I'm trying to achieve with this example. So we have one activity, and I can highlight the activity area if I create a new activity, open the new activity window. So this is our activity, and if I want to travel from this point to this point, probably I will need to travel uh, from inside all of these doors. So this space, this room has two doors, and this room has two doors. I don't know what kind of weird architect may design something like this, but there are many of them, and in some cases it might be a good choice. I'm not so sure about that, but I had been asked previously, how can we avoid entering these areas? So let's take a look at the paths that we will be capturing. So this is one path from this room, and you can see that this path goes in here and then in here, so enters this room, this path enters this room, this path enters this room, and these are not good choices. Okay, why they are not good choices? Why is it not that good to enter this area? It's because this is a personal territory of someone else. This is someone else's office, and then that someone else's office is considered as a private territory, and no one should enter that private territory. And if we just model that, then I guess we will have a good effect, and we can avoid entering this area. So all we need to consider is to consider the effect of personal territories. I'm going to clear the paths, and I've taken the liberty of creating new layers of data. So this is a layer of data that I have created, privacy 3, and if I just visualize that, you can see that these are private territories, these are private territories, whereas this is public territory. I mean, public in relation to the scope of the building. And then if for that activity I go ahead and include the cost associated with this public territory, then which is already written in a parameterized cost function, and then update this activity, then we will be capturing paths that look much more reasonable. So let's take a look at any of those paths. So I'm going to change the brush and make it some color which can be distinguished from the background, and then consider the effect of so this pass will be extracted, this pass will be extracted, this pass will be extracted. So there is no violation of personal territory. So if you want to create a realistic path planning system, then you need to think realistically too. So the realistic way of thinking is that these are personal territories, and the personal territories should not be violated. And I thought that this might be a common question for many of the people, and I decided to make a demonstration out of that. So another example that I would like to share with you is the example of a hospital. We would be talking about hospital in later tutorials because it's an area of research that this kind of tools like OSM will be really needed. So this might be an intensive care unit in a hospital, and then the nurses will detect the situation, the health conditions of the patients visually in many cases. And then I have created OSM environment for this hospital, and then I have also created a potential field for the nurse at the nursing station. So this nursing station in here, let's take a look at that. Is this potential field or activity is created for this nurse, and then um, so let's just take a look at the way that navigation is expected to happen in this space. So let's say from the bedside of this patient, the nurse takes this pass from the bedside here, here. So this is expected, right? And then what if we introduce a new layer of quality? And that layer of quality can be something like this. I don't know. I call that attraction and repulsion. And so this area is very desirable for any reason, and this area is not desirable. Maybe this area is actually mopped floor, and maybe this area is actually smelling so good and it makes attraction. I don't know. For any given, this is like a generic idea to make some area desirable and some area not desirable. And then I have also parameterized the cost associated to this this layer of data, and I'm going to include that into the cost function. So this was our cost function, and then the cost function is actually so simple. It's like a factor which is multiplied with the data itself, and if I include that in the static cost and then update the station, then I will go and recapture the paths with a different color, probably like I'm not sure what color might be good. Okay, cyan is good. And then let's say that um, I want to capture the path from the bedside of this patient. You see, this path is actually going all the way from here. It tries to avoid this area, and it tries to enter this area. What are the implications of that? I mean, this is expected. You may ask, okay, so we have seen that in previous tutorials. But with this change in the behavior of the nurse, what will be happening? The possibility of detecting visual help from the patients will change. So a patient, if the patient is in here, he will have a completely different chance of being visually detected from the previous scenario when the nurse could actually travel directly from here to here. So the previous scenario offered a completely different chance. So I want to make this point clear that qualities will make a framework for the behavior, and that's the idea behind social force model. It's not coming from me. And then if the behaviors change, everything is supposed to change. So for instance, the health conditions of the patients may not be visually detected. I don't know if this is the shopping mall, then the chances of getting visually detected will be changing, people visiting will be changing, everything will be changing. And if you take a look at the potential field in here, it might be interesting in 3D. So, sorry, I made this too large, and then I am going to visualize the station potential field in here, and since we have introduced this quality, okay, color code and contours, we need both of them. All right, I'm sorry for the aliasing effect that you may experience. And you can see that in this area we have nearly flat and nearly flat quality, and in here we have like a sharp changes. So this is the least accessible area, and it's because we have introduced this sharp edges, this quality in here, which produces sharp ascending into the potential field. And this is nearly flat. Technically we do not have a flat area because the potential field should always suggest something, and if the steepest gradient should exist, then we will not have something flat at all. All right. Well, I guess this could be a good point for us to conclude our discussion about activities in mandatory occupancy simulation model. In the next tutorials, we would be talking about sequences and the scenario in mandatory occupancy simulation models. And I hope you have found this tutorial interesting, educational, and hopefully entertaining. See you later.